For this video, I want to briefly talk about the double angle identities or the double angle formulas, as well as the formula for the unit circle. So we won't go into these two in depth, but in grade 12, you're going to learn how to prove these and why these work. So whenever you see sine 2a, you can rewrite this as 2 times sine a times cosine a. So something like sine of 180 degrees. Well, that's the same thing as sine 2 times 90 degrees, which is the same thing as 2 times sine 90 degrees times cosine of 90 degrees. And so I'm not going to do these for all of them, okay? But the ones I do want to focus on the most are cosine, and the 3 different instances of cosine 2a. Tangent 2a, I guess it is important as well, but you rarely see this in calculus. The most is these two. If you look at sine squared a, it looks something like this. Cosine squared a, it looks something like this as well. Once again, you don't really have to copy these down, but you do need to know them by heart eventually. Okay? They are in your workbooks, so if you ever forget, you can go ahead and look at these. The only one additional thing I want to do is, I want to go over the unit circle. Sine squared theta plus cosine squared theta is equal to 1. Or in other words, x squared plus y squared is equal to 1. By graphing this, you have a circle with radius 1. So let me see if I can draw this properly. Nope. There you go. Okay. We have a circle of radius 1, where this is 1, 1, negative 1, negative 1. Regardless of what theta is, and you might have learned this in Math 910, if you ever have sine squared theta plus cosine squared theta, as long as these are the exact same, you're going to get 1. Something similar, x squared plus y squared is equal to 1. I'll actually write out the generic formula. X squared plus y squared is equal to r squared, where r squared, or at least r, is your radius. So if I erase this, if I say, oh, x squared plus y squared is equal to 9, this is the same as x squared plus y squared is equal to 3 squared. So if you draw a circle with this equation, that means you have a circle with radius 3. 3, 3, negative 3, negative 3. If you have draw x squared plus y squared is equal to 16, well, that's the same thing as writing x squared plus y squared is equal to 4 squared. So you now have a radius of 4. And why this is important is because, well, sometimes you might get a trick like this. Oh, draw y is equal to the square root of 1 minus x squared. And although this seems pretty daunting to plot, it's actually quite simple. So one thing I want to do is this. I want to show you that, okay, this is positive. So we only take the positive and not the negative. And you'll understand this in just a second. But let's go ahead and square both sides. Y squared is just y squared, and this whole thing squared is just 1 minus x squared. If you add x squared onto both sides, we get x squared plus y squared is equal to 1, which is what we had before, that unit circle. But we can't draw the entire circle because, like I said in the beginning, we were only focused on that positive half. So instead of drawing that full circle, I'm going to go ahead and just draw the positive half of that circle. Oops. like this, from 1 to negative 1. And you can still have something similar. You can say maybe, oh, y is equal to 16 minus x squared. We are still taking the top half because it's positive, but if we squared both sides, we get y is equal to 16. Oh, y squared is equal to 16 minus x squared. Add x squared onto both sides, and instead of writing 16, it's 4 squared, so we now have a circle with radius 4.